I'm Joel Koska. I'm a professor here at Georgia Institute of Technology, and I work in the area of biology, specifically microbiology, but then also in the Department of Earth and Atmospheric Sciences.
And what was this paper showing that was different that we didn't know?
The advance of this paper is that they show that microbes can exist in tiny droplets of water inside the oil deposit itself. So we used to think that most of the microbes and the microbes that were active or potentially affecting that oil deposit were kind of at the edges of the oil deposit where oil and water mix. What this paper shows is that you can also get microbes that eat oil inside the oil itself in these tiny droplets.
So these microbes, they're using the oil for food, but are you saying that they can't live directly in the oil?
It's been thought prior to this paper that the microbes couldn't live very well inside the oil itself because there's very little water. Oil is a liquid also, and very important is water, right? Our cells are mostly water, microbial cells are mostly water, so microbes need water. And in the middle of an oil mixture, you don't have any water. So what these researchers show is that drops of water inside of the oil can support microbial life.
So, of course, we know that oil and water don't mix. If you've ever made a salad dressing, you see that the oil floats on top of the vinegar. So, how do these water droplets come to be inside the oil?
Well, it's thought that the water that is involved in the production of the reservoir, so the reservoir is deep below the ground. That subsurface contains rock deposits, these oil deposits, which are produced from plants millions of years ago that are acted upon over geologic time in the rock. And then it also includes water. Water filters through the cracks and the fractures in the oil deposits. And so it's thought that as those oil deposits, which are under a lot of pressure, as they push towards the surface, they entrain or take up some tiny bubbles or drops of water as they move towards the surface.
And how small are we talking with these drops?
Just a few microliters of water. It's probably the amount of water that would be contained in the head of a pin or less.
Wow, that really is a tiny amount.
Yeah.
So, how are these bacteria surviving in such a small space if they can't move around much? And what do they do for food and things?
In general, the types of microbes that you find in water indicates their function or their activity. What do they do in the environment? And so these researchers studied what they do in a variety of ways. First of all, they just studied what types of microbes were there. And from the types of microbes, we can infer what their metabolism might be. And the way that they determined what they might be doing there is they studied the chemistry of the water. And so you can study basic nutrients that the microbe needs. And then they can also use more geochemical methods to study the hydrocarbons, the food that's present, to show that those compounds were changed by microbial life.
This is a little kind of microenvironment for the bacteria, and there's everything they need to survive in that tiny bubble.
Exactly. I think it's really interesting. We don't really know how long these bubbles last. How long does it take from when they're created deep below the ground to move up towards the surface of the earth? And you can imagine if that happens over thousands to millions of years, the microbes have to have whatever they're eating, whatever they're using to survive in that really small space of the droplet.
So, this is all really interesting, but are there any practical applications that now we know these things exist? Is there anything we can use them for?
So in these petroleum reservoirs deep below the ground, it's very warm. There's no oxygen, it's anoxic, and we find a lot of natural gas produced, methane. And what happens is, over geologic time, microbes convert lighter oils to heavier oils. And so understanding the types of microbes that do this, that create the methane and create heavier oils from lighter oils, can really help us to understand how we can recover energy from these oil deposits deep below the ground. Something like 2/3 of the oil in oil reservoirs are not obtained by drilling and pumping out of the ground. And so there's a lot of oil left over in oil reservoirs around the world that we would really like to access. This research will help us to understand how we can access that 2/3 of the oil in oil reservoirs. microbes that live without oxygen can convert those hydrocarbons into methane. So by understanding these methane producing microbial communities in these tiny droplets, we can better design strategies for recovering that energy from these deep reservoirs.
If we can't drill down and get the oil out as oil, we could perhaps pump in more of these microbes and have them turn it all into methane, which we could then extract somehow.
We call that bioaugmentation. Microbes that are native are much better at degrading oil hydrocarbons than anything we can add to the environment. So the search for the superbug has really not worked out yet. Another thing we can do is what we call biostimulation. We can try to add something to the ground, whether it's oxygen or nutrients, to stimulate the native microbes that are there. So in this case, it's an anoxic system. We'd have to add some kind of nutrient that would make the methane producing microbes grow better. And in order to design such a strategy, we really need to understand the metabolism of these microbes better. And so what this paper does is to understand the native microbial communities so that we can access their metabolism to create methane from these hydrocarbons in the deep subsurface.